Welcome to the Truelty UI training. In this training course, we're going to go over a handful of things. One, how to log into the portal. Two, how to add new tables to our set of tables to be processed and how to configure them. Three, how to map the columns in our each table and how to run a pre-flight checklist before processing our data. So let's get started. When you are set up in Truelty for the very first time, you will receive an email sent to the email address that you indicate as your email address and user ID. Once you click on that email, it will run through a process where it will log into the portal to allow you to add or create a password for your account. And from that point moving forward, you'll use that email address as well as the password that you assign for your user for the portal. And like any web UI, if by chance you've forgotten the password, you can run through the forgotten password process and it'll resend or reissue a new invite email to or new invite to that email address. If by chance you just need to get to the Truelty app and you don't have it bookmarked, it's just app.truelty.com. So pretty easy to remember. And then we can go ahead and log in. Once we logged in, we're going to see our dashboard. Now, for the very first time you log in, before we've configured source tables and map columns, when this comes up, you're going to see it. It'll look a little goofy because there's no data to be able to present behind the dashboard. Don't worry about that. That's just a heads up. Now let's quickly go over the dashboard at a high level as to what we're seeing on the dashboard. So of course, what we see here is the last time that we ran the processing. So in this case, we ran on November 23rd at 12:35 p.m. The number of records we processed was 30 million. The elapsed time it took to process from beginning to end chronological time was 3 minutes and 34 seconds. And in that 3 minutes and 34 seconds, because we run in parallel processing, the total amounts of estimated credits of Snowflake was 0.933. Down in you'll have two sections. You'll have the combined set of all the tables that were processed and the individual tables that were processed broken out up to 10 tables. So if you have more than 10 tables, it's going to show the top 10. But this will show all tables considered. Now, you'll see that the deduplication percent in this case was 44.58% of the records identified in any of the tables matched. Okay? Now, I want to show you kind of how you can understand what just happened. If you place your mouse over either the purple bar or the green or teal bar, you'll see in both cases a pop-up, and that's going to identify the exact count down to the record of the number of singletons, meaning a record that matched no other record either in its table or any other table that was selected to be processed together. So there was 16.6 million singletons that were processed. And then on the match side, which is represented by the teal color here, that represents the number of records that were matched across the board in either matches in the same table or matches across different tables. And likewise, when we go down to the tables themselves, we're going to see a similar view, which is going to show the singletons for that table and the matched for that table. And so that gives us a kind of a high-level view. There are some other places that we can get this same information, but from the dashboard, that's where we're starting. Across the top, we've got 4 different critical tabs. And for all intents and purposes, this is the bulk of what we will be doing as we add new tables and map them. So we're going to start with our sources. In our sources tab, this is identifying the tables that we're going to process. Now, in Truelty, one of the things we do is we don't want to try to source from your production tables. So when we do the setup, there's a database created called Truelty, the Truelty database. In that database, there are several schemas. Um, all of those schemas except for two are intended for internal processing of Truelty. One of those schemas is called LZ. LZ is where you're going to put a copy or an iteration of your production table that you want to process for identity management into that LZ and maintain that table up to date as often as you need to. Now, we do that for a couple of reasons. Principally is A, we don't want to be trying to work with production tables that may be in flux or may have some challenges to the quality of data in those tables. That's one. Number two, it's not uncommon as you look at what you want to validate in your table that you may identify certain tables that you want to use, but there may be more columns than you need. And so allowing us to isolate what you want to use for your identity matching, you may choose in your processing to remove some columns. Um, Likewise, one of the critical things that we need for every single table is that every single table contains a unique identifier, or think of this from just a pure SQL point of view, a primary key column, meaning that that primary key column value is unique for each record. In some cases, you may have a table that requires a compound key, meaning that the key is actually made up of multiple columns. In those cases, what we need you to do is combine or concatenate those columns that are part of the key together and create a net new column that we will use as the identifier for primary keys. Why do we do that? A couple reasons. The biggest one is that, as you well know if you've worked with Snowflake, is that Snowflake does not, as most SQL databases do, but in the case of Snowflake, it does not honor the concept of validating primary keys by nature. And so we have to do that separately and be able to identify those separately. Once we get into our sources, if we need to add a new table that we've already placed in the Truelty database LZ schema, we can simply hit this Add Tables Plus button here. And what that's going to do is that's going to go out to that directory securely and interrogate to see if there are any new tables or if an existing table that we've already identified and mapped has changed. If it has, that will be indicated. If it's a brand new table, when it comes back, you will see the source name blank, and you'll see a default value for the loading method, and you'll see that table indicated as inactive. Now, your source table is going to have the table name. However, you may identify or identify a need to give that a more business-friendly or simply identify it somewhat differently than the source table name. So we'll allow you to put an alias in here. And so let's imagine I want to call our customer table, I'm just going to call that what everybody calls it, we call it the Orders app. When we identify each table, one of the things that we're wanting to understand is when we load that table, are we loading the table as a complete refresh every time we run it? Okay, so I clear out the table and I completely reload it, or each time am I doing a form of a update or an upsert, if you will. For new records, we're inserting in, and for changed records, we're doing updates. I would recommend, for the purpose of being able to maintain our unique key that we generate that allows you to link back to your data, is that we avoid deleting records from our process. Because what can happen, not commonly, but it can happen, is as we process the data, one of the things that we do is we create an anchor record. Okay? And the anchor record is how we generate the cluster key, or the key that is generated by Truelty that maps to your unique identifier. If you remove that key, we have to regenerate that new anchor key. And so we want to try to avoid that so that we don't change the cluster key, so that you can consistently use that. However, if the anchor key is removed, we will generate a new cluster key for the set of matched records. Just a note, if a record has no matches, the cluster key will always be consistent. It's only in the cases of match sets that this can propose a challenge. So for the most part, I would recommend you do updates, as well as ensure that you avoid doing hard deletes. If you need to do soft deletes and you need to have that part of the key, you can add that back into part of your key. Last of all, from a configuration point of view, as I mentioned, when you bring in a brand new table, you will see it automatically show up as inactive. So before you are able to process or configure the table any further, we need to change that inactive to an active state. Okay. Now you'll notice in Truelty, as in many other UIs, that the elements that have been changed or altered are going to show up in this darker purple, where things that have not been changed that we can change are the lighter purple. You'll also see additional columns that kind of identify additional information, like what is the full path to the table, what was the number of records in that table at the time we refreshed it, the number of columns, and then since the last time we processed it, how many records were matched versus how many records were singletons, the date we created the table, the date we last updated the table, and the date that we last ran a matching. You'll also notice that if we make any changes here, of course, the save button and the undo button or discard change button goes from grayed out to usable. And so in our case right here, we're going to select this table to be saved. And so those will be saved. It'll refresh the data in the system, and you'll notice that it comes back and identifies that everything's good to go. So that's configuring tables. Let's go ahead and come to our columns. Now, in our column section, what you'll notice is that we will see the alias name that we can create here if we've created one. If we haven't, it will show the name of the table. However, in the case of an alias, you'll notice that when I float out over any of these, it does give me the full path and name of the table that is sourced out of Snowflake. Now, what you'll need to do when you come in here, you're going to see some colors along the left-hand side. They're either going to be green, as these are right now, or they're going to be yellow. If they're yellow, what that indicates is that either it's a new table or something in that table has changed and we need to review the mapping. Now, when we come in with a brand new table or a change to a table, and you come into the column section here, what you may see is that there's a processing happening. And sometimes that processing could be in a few seconds. In some cases where the table may be very wide or very deep, or the combination of the two, it could take a minute or two. Let me explain what's happening. When we add or change a table, a flag is identified that says, hey, this is new or changed. And a process runs in the background when we come into this screen for anything that is set to active but is new or changed. And what Snowflake does is it runs through a process that Snowflake has built into it that looks at each column in our table and tries to match it to a semantic category that Snowflake has predefined. Now, those predefined semantic categories are very useful because it will auto map most of our valuable fields. However, it's not always perfect like everything. And so what you'll see when it automatically maps is you'll see the name of the column that your table has, and then you'll see a semantic category that it was associated with. Some cases you're going to see that it comes back as do not use, or it comes back as do not use because it couldn't find a semantic category to match to. Now you can identify whether that's the case by simply looking clear over here under the auto class score. This is a score that is given to us by Snowflake. If it feels that it's a perfect match, we'll get a value of a 1. Anything less than a perfect match will be diminishing from 1 all the way down to none. And so in the case where we've identified something is either do not use or it could find no automatic semantic category match, you will see those blank. Now, a couple things to understand about semantic categories. It is the semantic categories that we focus on for doing matching. I'm going to explain 3 critical types of semantic, or 4 critical types of semantic categories. Let's start with the first one. As I mentioned before, each table needs to have a primary key, a column that represents the unique value for every single record. And we need to make sure that maps. Now, by nature, that will not automatically map. And so what we need to do when we come in here, this may be set to do not use by default because it didn't find a semantic category. We need to go in our list and scroll down to source unique ID and select it. Now we already had it selected for this case here, but we need to select that. This is critical. We can't proceed until this is fully done. Now, Truelty will not validate our changes until we save it. So even though I've selected source unique ID, you're going to see that it still says, hey, this hasn't been mapped. And that will stay that way until we hit save. And that way, because each time we are doing reads and writes to the metadata in the Snowflake database. Now, the other thing that you will find is you may get a semantic category mapping automatically that you choose not to use. Okay, now this is important. I'm going to give you an example that I created in our demo set here. It's very common that we might have in our data, if we're matching, for example, an entity that is a person or a place, we may have multiple addresses. However, we may find that maybe 1 or 2 of those addresses, that the data quality in it is very poor, or even more concerning, that the values that are stored in there are highly repetitive. Okay? When we come across those scenarios where we have highly repetitive data that does not bring a great value to matching, we will probably want to set it to do not use. Now, you can do some tests to validate what's the best way to do it, but what you're going to find is many columns may not bring a lot of value to the matching process. And so we want to avoid additional processing where we don't need it. And so we can set those to do not use. Likewise, if we have, and so most of these, like in this example here, automatically mapped. But for example, if for some reason our mobile phone did not map to a phone number, now just take note that mobile phone and home phone go to the same semantic category. There's no difference between phone numbers because we want to compare across phone numbers because it's not uncommon for a mobile phone to get in the home phone's place or vice versa, and so we treat those as a combined set. However, if by chance that it didn't select the right one and we want to set it to phone number, we can come in here and apply that directly. Now, I want to talk about this one right here, and this is an example of one. So by default, the list of semantic categories is broken up into 3 types. The automatic types that Snowflake supports, the source unique identifier, and the do not use, which are Truelty's custom or categories that it uses, and then custom categories that we can create. I'll go into a separate video to go into more details about how to add or change semantic categories to meet your needs. But it's in these custom semantic categories that we can include things that are unique to your business. For example, a loyalty program ID, which could consist of a number or alphanumeric or anything of that, which Snowflake would have no idea what it was. And so these uh, special identifiers that are important to you, like a loyalty program or a customer ID, or a location ID, or anything that you want to use that brings value to matching, we can create a custom category that will be used over and over again once created and consistently processed the same way. And so those are the kind of the three different things, the automatic ones, the ones used by Truelty, and of course the custom ones. Now I do want to talk about a couple other items here to help cement how the mapping works, how the matching works, and how we kind of identify that. You'll see with each column, based on the table that we selected, you're going to see the name of the column, you're going to see the semantic category that we match to, and I thought I selected that, but let me just double check. The semantic category that I match to, I'm just going to let that save so that I know that those are set. Um, And so you're going to have the order of the column. Now you can sort any of these by anything. So if you want to look at it by the column name or the ordinal numeric value, you can do that, or the data types. But it's going to tell us the column, the semantic category it's mapped to, the order, and of course the data type that we're expecting in the from the table. There is a column here called validated. What is this used for? There are some columns in our data that we may go through a process, not on our side, but on your side, where a step is taken to validate, for example, an email address or a phone number. So typical use case is somebody has subscribed or requested access to a system and you send out an email just like Truelty does. In that process, it sends it to the email. Once they respond to that, we can determine that that email has been validated. If you know that there are columns that are important for matching that also go through a validation process, we want to be able to identify those. What does that do? It gives us just a little stronger matching or credibility for those columns identified as validated for that table. So, for example, perhaps we validate the email, so we might set that to validated. Now, the other thing that we want to talk about here really quick is this identifier type and this score ranking. Now, to understand how Truelty works, because we're focusing on semantic categories, which gives us the flexibility to look across multiple tables, multiple columns that are of the same semantic category, and use that to cross-link to identify people, one of the things that is critical to us is understanding of the columns that we're going to use, how do we rank them as far as value? So let me give you an example. If you look at, for example, the US street address, it gets a value for identifier type of excellent. Now we, just like Snowflake, we kind of use t-shirt sizes here to kind of identify those. And in this case, the excellent ranking gets a value of 5. Whereas we might look at the name, and there's lots of John Smiths, and there's lots of Kathys, and there's lots of Jans and Joes. And depending on the quality of that first name, we may find that using that for a matching may not be as good as some other columns. And that's okay. And so we might, in this case, we map that not as excellent, but good. And you'll notice that the ranking is 2. Do not use, obviously, is set to 0 because we're not going to use it. And then let's take a look at this one right here, a U.S. state or territory. Well, if I've got several million records or 100 million records, and they represent my customers across the U.S., I'm going to have states repeated over and over again. And although that may sound like this is very valuable, from an approach of doing semantic category pattern matching, you'll find that although those values are there, they bring very little to A, the quality of the match, and B, they extend the processing time. Now, you may want to test this, and you may want to test it with different columns to ensure that you're getting the best matching possible. But I think what you'll find is that trying to, if you will, force fit or bump up the value of semantic categories that provide diminishing returns is only going to run longer, take more snowflake credits, and get you very little. So that's just a heads up on that. I want to point out one special type, and I've applied that to our custom loyalty program semantic category. And this is what we call an exact match. This is something that would be akin to maybe a loyalty program, or maybe a US passport, or a driver's license number, or a social security. An identifier that is so strong that for the most part we would consider it, if one record had it and another record had it and those matched, almost a match set. Not completely, but close. Now, let's talk about the rank score. When we look at the rank score, to create a matched set, okay, so this means that record A and let's say record B are indeed the same entity or person in this case, we need to hit a score of 15 or higher. And so if you look at the rank score here, and you look at the values, and this is the way that we have it set up by default, any value that is excellent or exact, or if you want to think of it this way, has a score of 5 or greater, those are going to be used as our primary matching sets, okay? So that we can get to our match sets as quick as possible without additional processing of non-important columns. And so to get to 15, one of the things that would have to happen, so just to give a quick example here, if I matched my street address, and I matched an email, and I matched either my mobile phone or my home phone, okay, and got to a score of 15 between two records, I would consider those records matched and chained together. And those records would show the same Truelty cluster ID, even though they're mapped with different source unique identifiers to their respective rows in their tables. However, if and let's say that our loyalty program is an ID that we are very confident is very exacting, if I got a match of the loyalty program between two records and then simply one other match, whether it be email or phone number or address, that now equaled 15, we would consider that a match, okay? So that kind of helps maybe understand, and we'll talk more about this in the advanced course, as to what happens. Last of all is we've got these values here of regex. Now, the regex allows us to mainly focus on cleaning up common known problems in our columns. Give you a couple examples. When we're matching, one of the things that's important is that we remove superfluous characters. So probably the easiest one to understand is if we think of a phone number. There are many ways to write phone numbers. Sometimes we put the area code in parentheses. Sometimes we put dashes between area code and the split of the phone number. Maybe we use spaces or maybe we use dots. The problem is when we're trying to match those extra characters just create noise for matching. And so what we do here in the regex is we either tell it what to include or what to exclude. And in this case here, we're telling it only include data of this type. And we're just using standard regex that Snowflake supports. And so this allows us to do a pre-cleaning of commonly known typical challenge for matching. Now, all of the automatic and built-in semantic categories that come with Truelty already either have the regex added, or in the case where it's blank, we're taking everything in that string. If you add a custom one, you want to look at some of the ones we've already created and think about what your regex should look like. Now, once we've mapped the source ID and we've set that to the source unique ID and we've got everything done, Then we can go ahead and save it. And once we save it, we'll see that it says, okay, everything's saved. It checks to make sure that we've got our source unique ID and we're good to go. Now we'll need to repeat that process for any table that either we want to change a mapping, or when we come in here, that mapping shows up instead of with a green value with a yellow one, which indicates something has not been mapped or still pending to be mapped. But once we've got all green and we know that we've got the mappings the way we want to, then we're, for the most part of the configuration side of things, done. The one last thing that we're going to do is a pre-check. Let's talk about what's in the pre-check. Now, as we talked about a couple different times in our UI discussion, it is critical that for every record, we've identified a column that represents a unique or primary key column. It is critical for us when we run this that every record has a unique value there. Also, it's important to ensure that every column that is the source unique ID has no nulls. Okay, this is critical, especially as you work with or have experience with identity resolution. Duplicates and null values can create kind of some cascading events. So we want to make sure that those are properly addressed. The other thing that you're going to see when the pre-check runs is it's not just going to check the active tables, it's actually going to check all your tables, whether they're active or inactive. And it's going to look for those challenges either with duplicates or nulls, but it's also going to look to make sure that the source unique ID has been mapped and that there are no columns that it doesn't know what the final mapping is. Now, what can trigger that is we may have created a table and made a change to it, or again, a net new table, but it will identify that. For all of your active tables that pass the pre-check, you're going to see a green value here. If it's not green, it could be caused, and if there is an issue, there'll be a text here for it, or we've set the state of the table to inactive, in which case this will be purple versus green, indicating the tables that are active and good to go. Now at this point, just to touch a few more things, at this point we'll have another training to go over how to run the Python side of this equation, how to configure it, how to run it both manually and as a scheduled process. And that you will set, and that is the component that connects to Snowflake, generates the code, and submits it to run in parallel on Snowflake, and monitors it, and then finally logs it. But one last thing is this. When you come into Truelty, if by chance you need to either log out, which we recommend when you're done, go ahead and do that, but more if you need to change a password for the Truelty user that we create named _Truelty_UI. If that password is changed, and you can rotate that or change that password as needed, but if you do, you need to come into this section right here and update that password. When we set up your account for Truelty, we will pre-populate these values. And for the most part, they're always the same with the exception of the account number. And of course, the password that you'll put in to be able to connect to Snowflake. And like I said, if that needs to be changed, if you rotate the key, this is where you come in and are able to make that password change for just the Truelty UID. That's been kind of the overview of and training for the Truelty UI dashboard and console. If you have any other questions, please reach out to us and we'll be happy to work with you to answer those. Thank you so much.